So we're now going to move on to domain, range, and asymptotes, right? Anytime you have an exponential function, you're always going to have an asymptote. I'm just putting that out there. And the domain of any exponential function is always going to be all real numbers, which in terms of interval notation is going to be from negative infinity to positive infinity. Or you can say x is all real numbers, right? That's the domain of all exponential functions. However, for the range, it's going to depend on your translation. So if you were to just look at h of x, which is equal to 2 raised to the power of x plus 4, if this positive 4 did not exist, right, if we said this was just h of x, which is equal to 2 raised to the power of x, we're going to say that the range is going to be from y and it's greater than 0, right? That means it's 0 to positive infinity. And the reason for that is because you have a horizontal asymptote at 0 if this 4 didn't exist. So if you have h of x, right, this is equal to 2 raised to the power of x. So you need to understand your parent function first before you actually deal with your transform function. So as you can see, so this is your exponential function, and you're going to have a horizontal asymptote at y is equal to 0. That's why when you're referring to your range, that means your range is going to be from 0, right? Y greater than 0, and y is not included, right? Therefore, it's going to be 0, comma, positive infinity. However, because you have 2 raised to the power of x and you have that plus 4, so that plus 4 actually translate your function up, right, by 4 units. So that's why for h of x, and this is equal to 2, and raised to the power of x, and this is plus 4. So now you're going to start at 4, right? So you actually do have a horizontal asymptote at y is equal to 4, right? So maybe I can extend our y-axis. So yeah, this is now your function, right? So it's 2 raised to the power of x plus 4. So you're seeing a horizontal asymptote at y is equal to 4, right? Initially, we had that at 0. So in that case, your range changes from 4, from 0 to 4, right? That's why, let me just write that down. So range is equal to 4, right? In terms of interval notation, this would be written as 4 is not included. That's why we have a round bracket, and this is to positive infinity or comma positive infinity. And we know that the domain is always going to be x, all real numbers, right? Or you can say in terms of interval notation, it's negative infinity to positive infinity, right? So this is just an or. And then if you want to state your range in terms of the y value, right? That means you would have y, and this is greater than 4. And what else? Asymptote, right? So your asymptote is going to be at y is equal to 4. So let's see what they wrote. Okay, so I don't think we need to do, or we need to take the log here, but let's see what they're trying to do. Yeah, personally, I wouldn't take the log because I think it's just time consuming. I think you need to understand your parent function and then you look at your transform function. And that way you observe what's happening to your transformation. I think that's the best way to go, especially when you're writing your test because you have no time to graph this and you don't even have a graphing calculator, right? So you actually need to know what your parent function looks like. So yeah, I would just focus on your exponential function because you're not solving for x, right? There's no point to be taking log and let's see what they're trying to do. And then have log y minus 4 over log 2. I think if you have x, which is equal to this, it just becomes harder to graph because first of all, how can you graph log y minus 4 divided by log 2 on top of your head? So I think just know the parent function and yeah, just stick to simplicity, right? Don't even complicate things. Just focus on h of x, which is equal to 2 raised to the power of x, and that's it. Okay, great. So, but yeah, the way they've drawn their function is actually right. However, I wouldn't go to that length to be looking for log and plotting your graph. So I would just say focus on the parent function. Okay, but let's see what they wrote. So in terms of domain, as x tends to positive infinity, then y tends to positive infinity, and as yes, y is equal to 4 is the only horizontal asymptote. Domain, they didn't really say what the domain is. Okay, so the range they're saying is all real numbers which are greater than 4. I wouldn't say all real numbers. I would just say the range of g of x is greater than 4. That's what I would say. Don't include all real numbers, because the way if you say all real numbers, that's generalizing that 4 is also included. So try to avoid that if you're trying to say y is greater than 4. So keep it this way. You're not supposed to say all real numbers. Okay, domain was not mentioned, so that's my comment. Domain is x is, let me just maybe type that here. X is all real numbers, or negative infinity. Okay, let me just quickly have the infinity sign. Okay, there we go. So negative infinity, comma, positive infinity, so that's there. And then your range, yeah, I wanted to say y is greater than 4, or you have 4, comma, and just make sure, because y is not including 4, you need to have a round bracket over here. Because there is a difference between having a round bracket and also a square bracket. So just keep that in mind, and horizontal asymptote is correct. So okay, great.